Okay, welcome back. In the first part of class, we started discussing Project 5. Project 5 is fundamentally different, and we saw web applications in action, right? We saw how we've got this brand new Maven project that contains this little toy application for maintaining a dictionary, and you can access this dictionary using a REST API by hitting various URLs. So we saw that our application runs in the background in this. Sorry, it doesn't run in the background. It runs in this in this Jetty web server, and it's the thing that handles all the HTTP requests that come from the web browser, come from curl, come from, as we'll see later, a command line program. Actually, maybe I should just show that now. That'd be a good thing to show now. So I just want to show all the big pieces, parts, and then we'll dive into unit testing a little bit. So like I said, there are some source files here. The servlet we've been looking at. There's also a command line, a main method of Project 5, and that gets built into a jar. Airline web. Oops. Oh, maybe I don't have it. I probably haven't run the right thing yet. No, airline jar. There it is. Airline jar. And this is a simple command line. It takes 4 arguments: the host, the port, the word, and the definition. So the host is going to be localhost. The port is going to be 8080. The word, let's see here. Me, a name I call myself. Me, a name I call myself. And so now when I run all of this, oh, oops, I saw the debugger going. It did a post. It hit the post. Okay, we've already seen this. I'm going to just stop debugging. Detach the debugger. And it said, great, define me as a name I call myself. The command line application can do other things if you only specify the host and port. It prints the entire contents of the dictionary. If you just give it a word, it prints the definition of that word. Same functionality that we've seen from like that web form, and the same thing we saw when hitting the right URLs. I mean, so for instance, if I go back to my web browser and I say, and I put a query on this URL, I can say, word equals me a name I call myself. So, the important thing to realize here is that your web server doesn't care about what the client is, right? It can be called from all sorts of different ways. It just speaks HTTP. So as long as it receives a valid HTTP request, it'll handle it. It'll handle it the same way. And there's power here, right? So now you can have different clients doing different things. So, and realize that these are 2 different processes, right? When you run, this is a Java program that runs the command line, calls the, invokes the REST API, does the HTTP requests, and then over here in this shell is the server that is then handling those requests. Next week we'll dive more into the client and we'll debug both processes and see how all of this stuff happens. It just gets a little bit more complex. So anyway, so those are the big pieces, parts of the assignment. And actually, let me see if there's anything else. I guess there is one more thing, and this is kind of relevant. So I'm just going to close. I'm just going to Control-C out of this. Now, you've got Java code, and we'll see that you can write tests for this Java code. And so we are, and because there are tests, I expect you to write tests for your Java code, and we will measure the code coverage of it using the same thing as before. So if you run with -p greater verify, it will run the unit tests, it'll run the integration tests, and then it will measure the code coverage. And for Project 5, there's the same code coverage requirements, the 60% or whatever it is, which might be more of a challenge because there'll be more code for you to write. Just to verify all of this, it runs the integration tests. And it said, great, all code coverage checks have been met. So, how do you test this application? Right, you guys have figured out how to test the command line. Right, you can write unit tests for certain things. You write the integration tests so that you can call system.exit. You can call, you can get what's written to standard out. but you're not calling system.exit, right? What would happen if you call a system.exit in your servlet? Yeah, your server shuts down. That's not what you want, right? If the user enters in provides you with a bad date, you don't want to crash your server, right? That would be bad. Okay, web programming 101, right? Don't crash when there's bad user input. Instead, what should you do?
Issue the proper response.
Yes, right. You instead say, oh yeah, HTTP for bad parameter. Actually, I probably got, this is missing required parameter, so this is a precondition failed. There's probably some appropriate HTTP response for a bad input. Right, so and this is an important lesson, right? This is just like when we were talking about exceptions and we talked about printing the standard error, there are different ways of interacting with the user. Right, the way you convey an error when you're dealing with a REST API is different from when you're dealing with a command line tool, or we're just calling a Java API. And this is why you should keep that user interaction at the periphery of your system. So inside your APIs, use exceptions to throw things. It's not until the very outside of your code base where it's like then is when you finally translate it into an error message written to standard error, or an HTTP 404 that's returned to the customer, to the caller. So, but sorry, I was talking about tests. So you're going to write all this functionality in your servlet, and it's going to be doing things. And so, how do you test the servlet? Now, you can test the REST API by starting up, Jetty, and then you can hit the URLs. And you can do that on the Java code, and we'll see that next week. That's how integration tests work for Project 5. But integration tests are slower because you have to start Jetty. That takes several seconds, and you got to run your tests, and your tests call the REST API. And there's network connections involved, and there's data conversion and all that kind of stuff. Wouldn't it be nice if you could just write simpler tests? And the answer is yes, you can, but there are some challenges. There's some new stuff that you need to learn. Now, if we look at our servlet, what is the code that we would have to test? I think it's like our do-get method. What does our do-get method take? An HTTP request, a servlet request object, and a response object. So if I want to call this code from a test, I've got to provide an HTTP servlet request object, an HTTP servlet response object. How do I do that? It's like some other API. I have to go. Let's see here. Is this a class? Is it an interface? What is it? It's an interface. Okay, so I guess I could write my own implementation of that interface and then have it behave the way I want. That's kind of that would work, right? But that's a lot of work for you to do. This is not an uncommon problem, where you have objects in your system that that you want to test with, but the object itself might be very complex. Think about like a connection to a database, or a big old object that has like tons and tons of logic, but you only need to test one method, one interaction with it. I think it's next week you'll learn about dependency injection. This will really come into focus next week. So I'm going to introduce it this week. So maybe I'm going a little bit out of order. I'm going to introduce some of these concepts this week, but then you'll see it a lot more in detail. You'll get further reinforcement of it in the dependency injection discussion. So I have a class that receives these objects, and I want to be able to test the logic of these methods. So there is a testing API called, there is a approach to testing called mocking, where the idea is that you've got these objects that provide some functionality. So they're not necessarily the code that's under test. It is objects that are provided to the code under test that interact with them, like your servlet request and your servlet response. And instead of providing like the real official heavyweight version, you provided an object that just does what you want it to do, right? There might be one method that you care about. So in this case, it's like the get parameter method, right? What do we call a request? Ultimately, all we do with the request is call the get parameter method. So what if we could just provide our test with an implementation of servlet request that just provides me, and when its parameter method call just gives me the value that I want. So then I can then test this code with a servlet request that only knows how to do one thing. There's a thing that needs to be done for that test. This is you actually can get that kind of object from something called mockito, which is a library that is used to provide mock objects for these APIs. This is some wacky stuff. This uses a lot of magic under the covers, but it works. And this is all covered, I think, in the dependency injection lecture. I sort of go into details here. It's really cool and it's really powerful, but it's just complex. It's probably one of the more advanced things that we do here in this class. There's a lot of magic. There's some reflection involved. Super cool stuff. It's fun to dig into, but at the very least, you need to figure out how to use it. Wasn't much of a sneeze. Eep. Yeah. Anyway. Okay. Here's what we do. So here's a test that verifies that initially the servlet contains no dictionary entries. So what do? I create my servlet object. Aha, I'm invoking new servlet. No magic there. I'm just creating my servlet. Okay, ultimately what I want to do is call doGet. Okay, and then what I want to say is, hey, listen, when I call doGet, well, what are the side effects of calling get? Of calling doGet? It doesn't, doGet, doGet returns void. So how do I know that doGet has done the right thing? Right. It writes some text to the response object and sets its status code. So ultimately what I want to say is that, hey, listen, when I call doGet with a request that doesn't have any parameters to it, nothing after the question mark, I want to validate that it prints out, hey, there wasn't anything in the dictionary. Okay, what does it print out to? Well, it prints to the response object. So here's how I do all of that. My call to doGet has a request object and a response object. My request object is of type, it's a servlet request, it's an HTTP servlet request. How do I create one of these? I use this magical mock method. This is a static method that's imported from the mockito library. And what I do is I give it a class object that says, hey, create me a mock implementation of this interface. So here's an interface. Give me an object that implements all of the functions of that interface. So it is, the thing that's returned here, is a servlet request. It provides all that functionality, but provided in a special way. I'm going to do the same thing with a response. I'm going to create this mock stuff. Oh, and by the way, I also want to mock out a print writer because I'm going to be interacting with that print writer in a special way. So I've got all these pretend magical objects. And these mock objects have a special property. Basically, when the methods are invoked on those mock objects, they keep track of the fact that they were invoked. So they sort of do this bookkeeping. So its functionality, these mock objects aren't so much about providing functionality, but we'll see that they do also provide functionality. But they have all this bookkeeping mechanism that then allows you to later interrogate and ask that mock object, hey, were you invoked the way I thought you should be invoked? And if not, hey, my test failed. So this is also a good example of given when then. So first of all, you set up all of your data. So you set up your data, you set up your object under test, which is your servlet. You then set up all of your sort of mock data that you're going to use to interact with it. So your mock request response and your mock print writer. And then you need to configure your mock objects to behave a certain way when they're interacted with. So there's this magical when method that says, hey, listen, when response.getWriter is invoked, then return this mock print writer. So what I'm doing is I'm configuring this mock response to say, hey, when get print writer is returned, return this one that's part of the test. Cool. Now I'm just going to okay, go and do your thing. I'm going to send my mock request and my mock response to my doGet method. Now, your doGet method, it doesn't know any better. It doesn't care, right? This is programming to the interface. As long as doGet is interacting with something that provides servlet request and provides response, it doesn't care if it's a mock or if it's a real thing. As long as the interaction is what it expects, it's going to be happy. Great. So you call do get, and then what? Well, now we need to verify. This is the given when then. This is like then I expect some stuff to be true. So what do I expect? Well, I'm going to verify that my print writer object had its print line method invoked with this string. The format word count was 0 words. Okay? So this is like an assertion. So hey, verify that like my mock object was interacted with in this very particular way. And if it's not, it fails. Then I'm going to verify that my response had its set status method invoked with the value scok. Now, from what you might recall looking at the servlet, this is what it does. But the whole idea here is that this allows us to interact with this servlet object that has all these other APIs and interact with it in a way that we can then verify that the right thing happened. So this allows you to do unit testing and also test-driven development with your servlet APIs. Now, this is a little different from the kind of unit testing that we saw in the previous projects, where it was like, okay, you're writing, you're invoking some method and it's maybe returning a value, or hey, you are testing your print writer and you are writing, you're testing your text writer and you are writing all of your text to a buffer in memory, and then we compare something. You use assert that your in-memory buffer contains a string, et cetera, et cetera. This is more about testing the objects that you're interacting with, but this is the way that our do-get method works. So the big takeaway is that, like, hey, try using this magic, and it'll work pretty well for you. Here's a more interesting set of interactions. Here, we're going to test that we can add one word to the dictionary, and that first of all, that the appropriate output is written to the servlet request, and then we're also going to interrogate the servlet to make sure that like its internal data was updated correctly. So here, we're going to mock out a post, right? We're going to call do post here. So first thing we do, set up our object under test set, our servlet, and then we're going to set up our mock objects. And this is kind of an interesting thing, right? How do you specify the parameters on the URL? Well, the way you do that is you create your mock request and then say, well, listen, when get parameter is called with the word parameter, then return the string word, which in this case is test word. Same thing with the definition. Parameter is going to return our definition, which is test definition. Then we mock out our response with the appropriate print writer, and then we use that same when that we did up here to say, hey, listen, when get printer writer on the response, when get writer is called on the response, then return our mocked out print writer. Then we're going to call our method under test, our do post. We're going to verify that the right stuff, that the correct things were printed to the print writer, and that our servlet response was okay. And then finally, what we're going to do is we're going to use like plain old Hamcrest to say, hey, listen, I'm going to ask my servlet, hey, if I get the definition for my word, does it actually is it actually the value that I expect? So this is not only testing the interaction with these objects, but it's also then testing the side effect, which is like, hey, did I store a new word in the dictionary? And so now when I run these are just plain old unit tests, right? I can run this in IntelliJ. This does not start up does not start Jetty, does not actually, there are no URLs involved. It's just running your servlet in isolation, providing this mock environment, and your servlet is none the wiser because it's only because every servlet API that it interacts with, you have provided this mock implementation, so it doesn't know the difference. Which is like perfectly okay, right? Because you're just testing the logic, that things are behaving the way they expect. So that's how you can write unit tests for your servlet. It's been nice and fast. It's a little weird. You got to set everything up. But this will allow you to do very rapid development of your servlet, sort of independent of everything else. You can also use the HTML form and all sorts of stuff like that, but you'll have to restart your Jetty every time you make a change to your servlet. It'll be really slow. and you won't get the test coverage that you need to pass that part of the grading. Questions on this? What do you think? Yeah.
So the state doesn't have to persist through server restarts.
Exactly. Yeah, that's what we were talking about that earlier. So in Project 5, you don't write to files anymore. No more files. Hey, save a tree, right? So everything is just there in memory. And that's fine for this assignment. Now, of course, in the real world, yes, you want to back up to a database or some persistent storage or put it in the cloud or whatever. Fine. Beyond the scope of this project. And there's no. You've already demonstrated that you know how to write to files. So yay, pass that. I'll endorse you for file writing on LinkedIn or something like that, right? It'll be fine. But now it's for this assignment, it's all about storing information in memory and formatting it too. So here I'm just sending back all of this there's the text words here in from the HTTP response. You'll have to format XML though. You'll have to send XML back. And depending on how you wrote your XML dumper, this could be really easy. Because you won't be writing to a file anymore. You'll be writing to a servlet response. Or actually the print writer associated with the servlet response. Let's see here. A couple more things, just general Project 5. There's the index.html. This is not a class in HTML. So I'm not going to, apparently I have a little bit of CSS there. That's nice. To put space between things. Here is my, again, 1996 style HTML of having forms. It works, I don't care. Actually, you know what? I say that because I was writing computer programming in 1996. Some of you might not have been born yet. So do you want me to explain what this is all about? No? Okay. That's fine. The whole idea is that you can have HTML and these form things will call call a get or call a post for the URLs with some inputs. So you've got that. So beyond the simple dictionary application, which is probably enough to get you started. If you want to look at other examples of servlet, there's a family tree servlet class in my code base that can provide you some more information on, or some more ideas for how to implement this. We'll talk about the client later, but when it comes to the client, there's something called a HTTP request helper class, which does a lot of the heavy lifting of actually making the URL calls. So instead of having to figure out low-level Java APIs for interacting with URLs, you have to figure out my API for my API for interacting with URLs. And also, if you're developing on a machine, like a shared machine, like when you run your code on the PSU machines or whatever, if you want to use a different port, you can say you can run Maven with -D jdhttp.port equals whatever, like 8888, to do that. This is not 100% accurate. The code that can be submitted is the same as the code before. So if you have things like resource files and stuff like that, that'll get submitted. However, you can't submit your POM and you can't submit the web.xml. I don't want you messing with those things. So if you think you need to mess with those things, let me know and we'll talk about it. But it's just one fewer thing for you to change and potentially break, or make my life hard, or make the grader's life harder. Yeah.
Sorry if I answered this earlier, but the HTML form is talking about like word and definition pairs, but we're going to be dealing with airlines and flights.
And actually, that's true of all the code, right? So the servlet deals with word and definition pairs. This is to start out with. This is a toy application for me to demonstrate all of this stuff for you and for you to sort of be able to work incrementally. The index.html is not part of the assignment. I'm not going to test that. That is there for your to make it maybe a little easier to test or to make it easier to develop. So yes, you'll have to add more parameters to it and change it around if you want. That is, the index.html is completely optional. I think I explained that there, right? Yeah, experimentation in open person is not part of the grid. And actually, you can't submit it. I think I put it in a directory that doesn't allow you to submit. Yeah, that's the web app. You don't submit that. So yes, so it's there for you to experiment with. So that's the beginning of Project 5. Any questions or about the assignment or about the functionality or what you need to submit or what you don't need to submit? It's due on March 4th, which I believe is 3 weeks away. Yeah, 3 weeks away. Nice thing about these 11-week terms is that you get a lot more time than people in the summer. They only get 2 weeks for this. Ugh, really? Maybe give them 3. But anyway, but there's a lot here. Don't be fooled. And what we saw is an introduction tonight. Just an introduction tonight. There'll be more to come. So on that, it's 7:22 now. We've got a couple of options. This is the last week of the pair programming. Has there anybody who hasn't done a pair programming activity yet? You have not. Okay. You have not either. Okay, a couple people. Okay, so I'll let you do the pair programming then. Next week, then, we'll go into more detail here. We'll talk about what happens on the client side, stuff like that. Let me tee up the kata. There's one other thing I know, and so then, actually, will it just be the two of them? Is anybody else going to stick around for pair programming? Anybody want to do some pair? And it's totally fine if you don't. If you have already done it, okay. If a couple of you could stick around after I tee up the kata, I got the department got some HDMI and some VGA cables. I was wondering if you could help me test out the projectors for next time. The department can't remember last time anyone actually used the projectors in this room, so I don't even know if they work. Yeah. So, and by the way, I mean, they're super supportive of me actually using this room the way it was intended. So, I've really appreciated how easy they've made things for me. So, they got me these, nice cables. How long are they? 10-foot cables. So, anyway. So if a couple of you could just stick around and just try it out to see if it works, and if it doesn't work, then I can tell the department that. So, because I do want to use them next week when we start doing mob programming. Okay, so for those of you who are sticking around and doing pair programming, our kata tonight is the lags kata. So this is a kata where you are writing some software for a small airline. Funny that. And here, what you're doing is you are scheduling flights optimally. As a matter of fact, this company is so small it only has one airplane. Maybe it's made by Boeing. Anyway, so the whole idea is that it's like the Uber of airlines. You call up and say, hey, listen, I want to I want to go someplace. And it's like, hey, here are some places I want to go. Well, they basically get these requests. They've only got one airplane, so they basically want to order the flights in such a way that they get like the maximum bid. So everybody calls and it's like, hey, listen, I'm going from this place at this time, and it'll take this long, and I'll pay you $10 for that, or $10,000 or whatever for your private jet. And your software then needs to find the optimal set of flights that will net them the most money. So the input to your program is like the name of a flight, and then the time it leaves, the time it arrives, the destination. Actually, are all these going to the same place? I don't remember. And then the last piece of information is how much the ticket costs. And so here, when provided with all this data, the best combination is this AF514, which leaves at time 0, arrives at time 5 for $10. And then this next flight, so at 5 o'clock, you can't make the flight that leaves from 3 to 7. You've already missed that one. But at 5 o'clock, you could do this next flight that's 5 to 9 for $7, or this one from 6 that leaves at 6 to 9 for $8. And so to make the most money, you do this one first for $10, and then this one next For $8, that gives you $18, and so that can run your airline apparently. Gas was a lot cheaper apparently when this was written. I don't know. So this is the kata that we're looking at. And so then what we're going to do now is I guess you guys can pair up. I'll be here to help you out and get you started and stuff because we'll do that. And then if the rest of you, thank you for those of you who are staying, could come up and either get a VGA cable if you have a VGA adapter or whatever, and just like plug into each one of these things. There's little ports over on the side, and just see if it works and let me know. Anyway, okay, thank you very much. I appreciate it all, and we'll see you next week.
See, they did not give any